In our previous videos, you have seen how solids, liquids, and gases are the three different states of matter. In this session, we will learn the kinetic molecular theory of matter and how it helps us to define solids, liquids, and gases even better. Moving to the kinetic molecular theory of matter helps us understand the particles which are present in matter and how it affects the different states of matter. There are five main postulates. The first postulate states that all matter is composed of small particles called molecules. It may also be made up of atoms or even ions. Okay. The second postulate says that these particles that make up matter, they are always in a state of continuous motion. Now you need to recall that whenever any object is in motion, it possesses kinetic energy. So similarly, because these particles are always going to be in a state of continuous motion, all of these particles are also going to possess kinetic energy. Okay. The third important postulate is that with the supply of heat energy or thermal energy to matter, the kinetic energy of the particles increases. If I supply heat energy to any kind of substance, the kinetic energy of the particles present inside the substance is also going to increase. And they will all start moving more and more vigorously. The same thing happens if I cool any kind of matter, right? On cooling a certain substance, the heat energy is taken out of it. Because the heat energy is taken out of it, the kinetic energy of the particle decreases and the particles become slower and slower in their motion. Okay? The fourth important postulate is that the particles attract each other with a certain force. This force is called cohesive force if the particles are of the same kind. And if the particles are of different kinds, then the force of attraction which exists between the particles is called adhesive force. Okay? Not all times every single substance is made up of one kind of particles. So substances may be made up of two or more kinds of particles also. Alright, so in those cases, the force of attraction which exists between the particles is called adhesive forces. The fifth and the last point states that the force of attraction between the particles decreases if the distance between them increases. Similarly, if the distance between the particles decreases, then the force of attraction between the particles will also increase. So these were the five main important postulates of the kinetic molecular theory, and these five postulates help us to define and understand each of the different states of matter. Explanation of a solid on the basis of a kinetic model. Now, the definite shape and volume of solids can be explained on the basis of kinetic theory of matter. In case of solids, the kinetic energy of the molecules is the least and the force of attraction between the molecules is maximum. The molecules of the solids can just vibrate about their mean position, but they cannot migrate from one point to another, right? And that is because of the strong force of attraction between the particles of the solid. Thus, the solid has a definite shape and a definite volume. Alright, there are so many examples of solids present around us. So, metal, wood, rock, all of these are examples of solids. In our previous video, we have defined liquid by talking about how it has a definite mass, it has a definite volume, but it does not have a definite shape. Now, in liquids, the particles are slightly far apart because of slightly lesser force of attraction in between the particles as compared to the solids. Because the force of attraction in between the particles in liquids as compared to solids is slightly lesser, right? What happens? There are small interparticular distance between the molecules or in between the particles. These small intermolecular distance allows the molecules or the particles to slide over one another and therefore move from one point to another. Which is why we can say that a liquid does not have a definite shape, because the particles are always in a state of continuous motion, which is the first postulate. Because they're in a state of continuous motion, what will happen if there is slight space in between the particles are going to try and move from one point to another. Okay, that is why a liquid does not have a definite shape, but it has definite mass and definite volume. In case of gases, the particles are very, very far apart, because of which we can say that the interparticular distance or intermolecular distance is very, very large. And this distance is much larger in between the particles because the intermolecular force of attraction is negligible. Moreover, the molecules have a very, very high kinetic energy. Remember that kinetic energy is the energy which is possessed in any kind of moving object. Therefore, the molecules are practically free to move in any direction. Therefore, they can fill in any space. Therefore, gases have no definite shape and no definite volume. It is because of the large intermolecular spaces that gases can easily be compressed. There are several examples of gases. Oxygen is one of the gas. We breathe in oxygen. Nitrogen is present in the air. 78% of gas in air is made up of nitrogen. Carbon dioxide, we breathe out carbon dioxide. So all of these are examples of gases.